So we'll go over the homework, but I want to get a couple things done. So I apologize for the chaoticness of the past few days. So Friday was a planned day out for me. My kids had a gymnastics meet in New York City. And then we picked up whatever this is that I got going on. I don't know if I got that in New York City or if it was from before, but I'm still sick. Don't know how long I'm going to make it through the day again. So I apologize for all the hopping around, and hopefully the material's still sinking in. So we'll start here. Just to be clear, did we talked about this page? This is the first page that we haven't gotten to. Okay. So we're going to start here with a concept called, it's not what I wanted to do. It's called orographic lifting. What is going on? All right. It's also called, more informally, it's called the rain shadow effect. So at the top where it says, or does it even say orographic lifting? No. Okay. So you have this picture of the mountain, right? Like in the upper left area, right orographic lifting right next to that mountain picture. And then you can also do rain shadow. Does shadow have 2Ds?
No.
Thank you. To the rain shadow effect. I don't know any rules. Okay, when I learned to spell in second grade, we still had what was called whole language learning, which means you just memorize things. I never learned the sounds of letters and things like you guys did. So sounding out a word is not something for someone my age. We just never learned it in New York State. My husband learned it. He's 3 years older than me. My brother learned it. He's 6 years younger than me. So that 9-year gap, we didn't learn how to sound out words. It's a thing. Just take my word for it. I'm not just an idiot. I was taught that way. Sean. Anyway, just like a shadow. You know how with a shadow, there's an area where the light hits and then your shadow is where it's completely dark. That's the same thing here, except, okay. So yeah, on the other side of your body, we got one side that has light and one side that has dark. With the rain shadow effect, it's the same concept. Instead of with light, it's with rain. And this is, I think, one of the neatest things that controls a climate of a location. So we're going to start off with, as you can see here, I circled the words windward and then leeward. What side of the mountain do you think the windward side is? Or why do you think it's called the windward side? Okay, good. You guys have already got one concept without me even teaching you. The windward side is the side the wind is like hitting, the side the wind is coming from. And that actually goes right along with what we were talking about, whatever it was, I taught you this. So remember that the wind in certain locations always comes from, or most of the time comes from a specific direction. So for us, which we're in the 40s, our wind is usually coming from the southwest and blowing to the northeast. So depending on where the location is, the wind might be coming from a different direction. But anyway, on this mountain, they tell you the wind is coming from this left side over here. So the wind is coming from the left, and that makes this the windward side of a mountain. Easy enough, right? Now, what does the wind have to do when it hits this mountain? And by the way, this is a whole mountain range. It's not just one peak. It's a whole range, like the entire Rockies, for example. If the wind is blowing and hits this mountain range, it has to go up and over. Guys, you good over there? Anybody need something? Okay. So the wind has to go over because it can't go under the mountain, can't go through the mountain, and it can't go around an entire mountain range. So when air hits this mountain, it has no other choice but to go up. Now, what do we know happens when air goes up? It gets what? Okay, so it does go up, but what happens to the air when it goes up? It does cool. So normally only air that goes up is warm air. In this case, it doesn't matter if it's warm or cold, its only choice is to go up. It's basically being forced up. And we know that when air goes up, it cools. What happens if it cools so much it hits its dew point? No, it won't freeze. It rains or precipitation happens. So it could be snow too. So again, air hits the mountain, it's forced up. When air goes up, it expands and cools, hits its dew point, and precipitation happens. So on the windward side of a mountain, this is always happening. Air is going up, cooling, hitting its dew point, and rain happens on the windward side. Anybody familiar with Portland, Oregon, or Seattle? And know anything about the weather in those locations? What? It's rainy. Seattle and Portland are known for rainy weather. Seattle is known for raining almost every single day. So that's what's happening here. The wind is blowing off the Pacific Ocean, hitting the mountain range and causing Seattle and Portland to get a boatload of rain because they're on the windward side of the mountain. So the windward side of the mountain, which I would like you guys to add to your notes. Do you still have a little bit of room left over here? Let's label this the windward side. We can label it as side the wind is hitting. And the windward side of a mountain, it will always be wet and cool. Which is helpful because windward starts with a W and wet starts with a W. The windward side is always wet. Now let's talk about the other side of the mountain. This one it's not as easy to remember. This is called the leeward side. So L-E-E ward. The leeward side. Okay, why will this side, so if you can see, I already have it labeled dry. Why do you think that side is dry? Sean, you got an idea? Nah, it's not quite it. Couple reasons it's dry. The first, you got an idea, Nick?
Not raining.
Yeah, so I'm asking why is it not raining on that side? That's literally one reason. One reason is, as that air went up the windward side, it got rid of all the water, or most of it. There's not much water left in the air because it got all dumped down on the windward side. That's one reason. The other reason is, so remember the air was forced up. What's air gonna do once it's up at the top? It is already cool. What do you think what do you got there, Cam? Then it's gonna go back down. So just like if you were hiking a mountain, the air does the same thing. It is forced up one side and it's gotta go down the other side. What happens to air as it sinks? It heats up. Remember, molecules get pushed together. It's called compression. So on this side, the air expanded. This side, the air is getting compressed. It's getting pushed tighter together, which means it's going to warm up. We also know that warm air can hold more water. So this side, the air is perfectly capable of holding on to any water that was left. This side is always dry and warm for that matter. So on the leeward side, we'll do the same idea. The leeward side is always dry and warm. My brother, and I think I've mentioned this before, he lives in Oregon. He lives on this side of the mountain. So Portland is about a 3-hour drive. So Portland's on the wet side, the windward side. To get to his house, we land in Portland, we drive over the mountains and come back down to his house here in Bend, Oregon, and he literally lives in a desert. This side is considered a rainforest, not a tropical rainforest, but a rainforest. And this side is a desert. It's not a desert that has sand and salamanders and cactuses because Oregon is still at the same latitude as us. It's 42 degrees north. So it's not hot enough there to have cactus and all those fancy lizards, but it is very dry. He only gets a few inches of rain all year long because he is on the leeward side of a mountain. This is the last and final thing we're going to talk about that controls our climate. In fact, we have just finished the chapter. So we finished chapter 8, which is good because we only have 28 days left of class. We are going to have a chapter 8 test on Friday. Guys, last time I had the test on Monday and you complained, are we now complaining about a test on Friday? What's your joke?
They said this is, oh, it's just 29.
Oh. Yeah.
Might go.
And by the way, it did still say 30 something on there for your class yesterday, but because of all the delays, I never updated it, and we officially only have 28 days left, which I think is kind of scary and cool at the same time. So chapter 8 test on Friday, so we'll do some reviewing tomorrow. One thing I want to do is kind of show you how the Regents is going to, oh wait, we never actually took the notes. Above the picture. This goes above the picture you were just writing on. Oh, let me erase. This page 15, right? Top of page 15, above the mountain picture. This is putting into words what we just talked about. By the way, if you remember adiabatic cooling, all that means is air expands. As air rises, it expands and cools. All right, and then the last thing underneath the picture just wraps this up. Talking about the leeward side. All right, now I want to go to some of the questions you did for homework that actually sums up this basically last part of the chapter we've been doing. So this is on page 19. All right. So page 19, right? Is that what it is? Page 19, these first three questions, 16, 17, and 18 are kind of like summarize the whole chapter, minus the water stuff. So this is all the climate stuff that you kind of got to know. They love questions like this. You're going to see this on your climate patterns lab, which I think Mr. Winters started yesterday, I think. Okay, so he's starting it tomorrow. Maybe Mr. Miga started it yesterday.
Yeah.
Okay, so Mr. Miga started it yesterday. I had to do the checkpoint questions and then we're starting into the actual lab today. But it's all about this imaginary continent. They always start off with it's an imaginary Earth-like planet, or they say it's an imaginary continent on Earth. The reason they always specify that is everything that happens on Earth is also going to be true about this example, meaning the equator is going to be the hottest place. It gets colder as you go north. The winds are going to be the same. Whatever happens on mountains and near large bodies of water is going to be true on this continent, just like it's true on Earth. And then they're going to ask you questions about this imaginary continent. And they use an imaginary one so that you actually have to think about it and not just go, oh, well, I know Africa is hot or things like that. You're going to actually have to use your knowledge about this made up continent. So the first question, which you guys I actually had you skip this one, or you were supposed to if you had read Teams, because this is about the stuff we just learned. Why don't you guys, even if you did this question, please try question 16 again, since you did not do it, or we had not learned it when you did it yesterday. So give question 16 a try here. So it wants to know about location A. Looking at the map, what do we see about location A and B? A is right by the ocean. And A and B are on opposite sides of the mountain. Which side is A on? The windward side. Yes, it's also the ocean side, but I was making sure you knew that it's on the windward side. So they're showing you that the wind is coming from the left and going towards the right and hitting A and then the mountains and then B. So A is on the windward side. That should help you decide. Can I cross off two of these? Which one? I can cross off 1 and 2 because they say less precipitation. A is on the windward side. The windward side is always wet and cool. So we have to decide, will it have a smaller temperature range or a greater temperature range? And this has to do with it being near an ocean. Being near that large body of water, what does that do to the temperature range? It makes it smaller. So that correct answer should be number 3. So those are two concepts that you need for that test, is you need to know that being near a large body of water gives you a smaller temperature range, just like Lake Erie gives us slightly warmer winters and slightly cooler summers, smaller range. And it's got more precipitation because it's on the windward side of the mountain. That's one type of question they might ask you about an imaginary continent. Here's another. Do you guys want to try and why don't you try it again? So double check your answers that you had down from last night, or if you didn't do it, please do question 17 right now. Again, if you don't know, I think you can eliminate answers because 2 answers make no sense at all. Actually, technically 3 don't make any sense. What's one of them that I could cross off? 3? So it is at a latitude that experiences longer average annual daylight. Why did you want to cross that one off? I agree.
It's for-
So that actually does mean it'll have longer annual daylight. Because remember, the equator always gets 12 hours of daylight. And as we go north, we get longer summers, yes, shorter winters. But there's actually something else, and that has to do with it's drier. Will having more daylight make it drier? No. What's another one I could cross off? Why can I cross off 2? That's not why I thought, but you're right, being close to a large body of water would make it wet. It's not why I would have crossed it off. We're comparing C and D. Is C really closer to a large body of water? No, they're almost exactly the same. What's another one I can cross off? Why can I cross off 1? They're both equally as far from the mountains or darn near close to it. I mean, if I got out a ruler, maybe one of them slightly closer, but they are both about the same distance from the mountain. So that honestly only leaves answer 4. Let's make sure it makes sense. It's at a latitude where air is sinking. What does air sinking cause that latitude to have? Guys, pretend your hands are air. Make them sink. And what are you doing? Higher pressure. When air is sinking, there is high pressure. Is there truly high pressure here, and how do I know? Yes, there is truly high pressure. How do I know? Right, remember, wind always blows from high to low pressure. So we know that 30 north is always going to be a high pressure area, and the wind are leaving. Well, just because it's high pressure, does that mean it's also going to be dry? What did I ask you to remember about high pressure areas? Hot, not dry and moist. High, dry, cool, and clear. So our high pressure is dry? Yes. And there's also one more thing. Remember this reference table. 30 north is labeled as dry. So you just had to check there. So the reason that C is drier is because it is located at an area where air is sinking. Oh, I didn't mention the winds diverging. Are the winds diverging here? Yeah, diverging means going apart. So that is answer 4. And question number 18 is review from chapter 2, which you do need to remember. I would literally bet my house that this question will be, a question like this would be on the Regents. They ask you this every year. Polaris. Who remembers what you're supposed to know about Polaris? Do you remember, Sam? It is the North Star. That's one thing.
It's where it is based on latitude.
Where it is based on your latitude. I had asked you to remember back in September or October that alt equals lat. Altitude of Polaris equals your latitude. So we're looking at location D compared to B. It says the observed altitude of Polaris at B is always, so keep in mind that D is about 15 degrees latitude, and it looks like B is around 40 degrees latitude. So which one of these is true? B is always greater, answer 4. You have to remember that altitude of Polaris equals your latitude. All right, those are the types of questions they're going to ask. Let me put up the answers to the rest of your I'm actually going to just do the first half here. So let's start here. Why don't you check? Well, I guess we're doing 1 through 17. Check your answers first, and then we'll go over any you want. Physically change the answers so I can see like which ones you're getting right and wrong as I just kind of walk around real quick. So make it obvious to me which ones you got wrong. Please. Oh, guys, were we trying or just rushing? So taking a look at these, it looks like there were quite a few that we should go over. Somebody give me one question that starts that actually, let's do this. Should we, go ahead, TJ, let's see what I was gonna do. Which one? One. Okay, that was actually my good, yeah. So good news, question one is not something I taught you. So if you didn't understand that one, that's okay. So it is talking about the interaction between atmosphere and the hydrosphere cause most ocean currents. What it is the wind is going to match with the ocean currents. So the winds are what's actually causing those ocean currents. Can you guys consider this your education on this one question? So I'm teaching you something right now. I very rarely have seen this show up on the Regents either, but the ocean currents and the wind patterns kind of match up. So remember how we talked about they curve to the right in the northern hemisphere? What you'll notice is the ocean currents are also doing the same thing. So if you follow them, they are always curving to the right in the northern hemisphere. So even these, if we turn them upside down, you can see that they are headed towards your right hand. Sorry, they're not showing up. So depending, you do have to put yourself on the arrow in the right direction like we talked about, but the ocean currents and the wind patterns all match up. So the wind currents cause the ocean currents. All right, now how about two or three? Anybody on those? Yeah, both of them? Three. High air pressure, dry climate belt is located. So that, remember, is with the ocean or with the wind current, wind patterns. So they label them dry and wet, and you should be able to add in if they are high pressure or low pressure. Remember where the wind, high, dry, so anywhere where it's dry will be a high pressure, or anywhere the butts of the arrows are will also be a high pressure. So we are looking for high pressure climate belt that's located at which of these? So I look at 0. 0's wet, so that's not high. I look at 30, that's dry, and the winds are leaving, so that is the high pressure one. The other ones are not. They're also in the wet location. What? Water's not gonna help. How about 4 through 8? Anybody have flashbacks to Mrs. Brown's class when you read question 5? You got it wrong? I'm telling her. Was she your teacher? Okay, then you're safe. I got it wrong. You can tell her. I can tell her? Guys, what are you supposed to know about monsoons? They are strong seasonal winds. And look at that. We're tying global together with some science. So she only had you remember that they were strong seasonal winds. We could go through the whole science. So remember, wind always blows from high to low pressure. So it does switch depending on what time of season or what season it is. But here we have winds coming off of the water. And what latitude are these winds coming from in the summer? near the equator. What temperature will winds be from the equator? Right, they're gonna be warmer if they're coming from the equator. And if they're coming from the ocean, are they going to be wet or dry? Wet. Then we look at the winter. Oh, okay. Then we look at the winter. We have winds blowing towards the equator from north. So they are going to be colder in the winter because they're coming from the north blowing to the south. They're also coming from the land. So are they going to be wet or dry? They're going to be dry. So we want summer to be warm and more humid than winter. That's answer 2. So you know the science, you just have to stop and think a little bit more. What other ones on this page? None, everybody else aced it? Cam, you got all the rest on this page, right? 6? Okay, which condition would cause surface runoff to increase in a particular location? Is this the one I gave 2 possible answers for? No, that was 7. It might have actually been 6. Nope, you're right. So we want surface runoff to increase. So guys, one thing I think I mentioned this on Monday when I was actually here for your class. If runoff's increasing, what's not happening? The water is not soaking in. I need to think only about one concept. So I think about water soaking in. And I know if runoff is high, then it's not soaking in. Which one of these will cause water not to soak in? And that would be taking dirt and covering it up with pavement. Water can't soak in through pavement. Can I ask which one you did put? So for 6,
4.
you put 4. Having a decrease in annual rainfall, that would be less rain, so less runoff. All right, if there are any more on these first 19 questions that you want to go over, can you please put a note next to them? And we'll go over them tomorrow. One thing I will say is if anyone who did not do the second half of the homework, so pay the rest, so 19 through the end, this applies to several of you who did not do your homework. If you would like credit on the second half of this homework, do it tonight, please. So that would be 20 through 41. Or if you know you just BS'd your way through that second half, I highly recommend going and finishing it and doing it for real so that you know what you do or don't know.